Okay. So, my other question I wanted to ask you about this. You have one or two problems where instead of telling you 0 to 2 pi is your interval you're solving over, what if they said negative infinity to positive infinity? How do you find all those answers? You don't. But there's a way to write it out to say, because in this case, we got pi over 3 as one of our answers. Okay. To get another answer that ends in pi over 3, I'd have to do what?
Add 2 pi.
Thank you. Add 2 pi. Go around again. And then add another 2 pi, and add another 2 pi. You just keep adding 2 pi all the time. So what? Or you could subtract 2 pi and go to negative angles. So what we do, if it's going to be an infinite number of answers like that, we say it's pi over 3.
Pi 3.
Well, our answer, I'm using pi over 3 as one of our answers. But you would put a plus 2 pi times n on it. Where n can be plus or minus 1 to, n could be any number of times you want to go around. So you simply say plus 2 pi n, meaning I would keep adding 2 pi however many times I need to. And so you would take each of those answers and you would just add a plus 2 pi times n on it. So that's all you're going to do on those. I would have said you just put, now if you're in degrees, you would have said you'd write 360 n on each one. Does that make sense? Big deal? All right. Then let's move to something with more pizzazz. Suppose I kicked you over to cotangents here for fun. And I said, oops, that's minus 3. This time, though, we're going to solve in degrees instead of in radians. Okay, once you're solving in degrees, your answers might be special angles, or they might not. Okay. As far as actually how you solve it, this one's got anything new and different? You think it'll factor? I mean, the bad thing is 12. 12 can be 1 and 12, 2 and 6, 3 and 4. Anybody with gut instinct, which one is it?
3 times 3 is 9 minus 3 is 4.
Okay, so I think I'm hearing more 3s and 4s. So 3 cotangent and 4 cotangent. We know the numbers in back half to be 3 and 1.
So it's going to be plus 1 on the left.
Okay, I'm hearing a plus 1 and a minus 3, because outsides will be negative 9 cotangents, and insides would be positive 4, which would make negative 5. So this part's nothing new. When I solve it, cotangent's going to equal what? It's going to equal negative 1/3, or it's going to equal 3/4. Okay, these aren't special angle values. So you don't know what actual angles you're going to need. It could be 37.6 degrees or something. So how are we going to find those angles? Calculator, yes. Now my question is, how did we get our calculators to give us angles? We did second tangent, second sine, second whatever to get the angle. But you don't have a second cotangent.
1 over second.
You're in the right idea. That's actually more trouble than you want to go to. If you're doing cotangent, secant, or cosecant, and you don't want to deal with them, just turn them upside down. If cotangent's negative 1/3, what's tangent?
Why did you not tell us this last time?
For what?
Last time? Flip them over?
No.
Oh, way to reach your voice.
No. This is, no. Okay. No, okay. You can't just flip them over. You have to use identities when you're working with solving. But now we're down to a single number.
So if we've had just one answer the whole time, we could have just did that.
Once you get, well, what do you mean? You didn't need to flip them over. Back here you got a cosine.
No, I meant unlike the last section.
Okay, well that was, that was verifying identities. You had to use an identity on it to flip it over.
No, I'm talking about anytime we've ever had to type it in the calculator. We could
Oh.
have just flipped it over.
Well, I haven't made you do that many things with cotangent, secant, or cosecant in the calculator.
We've done it before. Would that not be positive 3 or even or that?
No, that would not be positive 3. You're not doing, it's not doing perpendicular. You're not doing the opposite reciprocal. You're just flipping it upside down. So, now, the other thing I guess I should have asked you, are these possible values? What kind of values can tangent and cotangent have?
Tangent can be anything.
They can be anything. So yeah, if you see a tangent or cotangent, you know you got numbers that are going to work. Now you can pop it in your calculator and go, okay, I need the inverse tangent. It's easier for you and less confusing if you don't type the negatives in. That's the one thing I can't explain to you yet why your calculator gives you the answer it did, because I'm switching the order we're doing this chapter and I'm not teaching you the inverse trig functions first. We haven't seen the reason for why your calculator gives the answer it does, but for your sake, if it's possible for you to type it in without the negative, do so. It will cause less confusion. So, I actually have mine up. I'm going to show you that. So if I do second tangent of 3, I get 71.565. This book rounds answers to tenths.
I typed that into my calculator and I get 1.5.
Ah, okay. You all need to be in degree mode. You may well still be in radians because we last graphed. So you need to check that you got it set in degrees. That's important. We probably should make a note of that. Hit mode.
Got it. Hey, we're in degree reading.
You want to be degrees since we're solving in degrees. So this this few sections we're going to do right here, you will be flip-flopping back more between degrees and radians. So you'll need to always be careful of which one am I in. Okay, so you'll notice when I did inverse tangent of 3, I got 71.6. They're actually going to round it off like normal, but round it to 10. If you had chosen to do it with the negative angle, or the negative number, on sine and tangent, it's not bad. It just gives you negative 71.6. You should just ignore the negative. We're not doing angles going backwards. But let me show you what it does on a cosine. And there is a mathematical reason for it. I just haven't taught you yet the material to know why it's doing that. If I do inverse cosine of, well, let's actually do something we know. Inverse cosine of a half.
Why can't we just...
It gives me 60 degrees. But if I do inverse cosine of a negative half,
How'd you do that?
that's because it's programmed to know about, there's a special case with quadrants when we do inverse trig functions. We actually right now are not solving our problems based on these quadrants, but your calculator's been programmed that way. So what your calculator's doing is it's been programmed to give you an answer in the second quadrant for cosine. There is a whole reason for that we'll get to next week.
Is it because there's 180?
No, it's all about how inverse trig functions are defined. We haven't been through that whole mess. So what it's telling you is the second quadrant angle is 120, so you could figure out that, oh, my reference angle must have been 60. My recommendation to you is just always put them as positive numbers and you will not have to deal with this. All you need the negatives for is to tell you the quadrant you're in. Okay, so that negative tells me when I do this tangent, I'm in the negative quadrants for tangent, which are what quadrants? 2 and 4. And the 71.6 was my reference angle that I got on my calculator. So how are you going to figure out what the angle is from 0 over to that angle?
180 minus 71.6.
Yeah, 180 minus 71.6 is going to turn out to be 108.4 degrees. Then do the same thing if I'm going around here clear to the fourth quadrant. I've got to do what? 360 minus 71.6. And 360 minus 71.6 is going to be 288.4. Okay, are you done? Is that your answer? No, we got this other one. We had tangent with 4/3. So you also have to go punch it in your calculator, do inverse tangent of 4/3. This one's positive, so I'm in which quadrants? 1 and 3. So I've got to go punch that in my calculator to inverse tangent of 4/3. And I get 53.1. So that's my reference angle. So tough question. What's that angle in the first quadrant? Okay. You're scaring me. That's 53.1, and if I go clear around over to here, I would have 180, which would be 233.1. So in this case, you're going to get 4 solutions. Did I do anything to require me to check for excluded values? Nope. Didn't have any fraction action running here, so those are good. Plus, they're not on quadrant lines, so you're not going to worry about it anyhow. Now it's fun, right? Okay. Yeah. Because you're typing this division, it's going to be 1 divided by 3.
That's why you're freaking Sal out by not continuing.
1 divided by 3 is a third divided by 4 is 12.
Nice.
Yeah, you can't make divisions the order you want done when you have multiple multiplications and not yeah. All right, are we ready? We have one more major one, and then I need to show you how to do something with your calculator. What? Because to get your calculator to give you an angle, you have to do inverse tangent. No, this is for all. If you want an angle, because otherwise, if you just type in your calculator, if you just type sine, it is expecting you to give it an angle. Otherwise, it will tell you error. If you type sine of 5/7, it's going to tell you the sine of 5/7 degrees. It's not going to kick an angle to you. Anytime you want an angle, if you remember back to our Oscar had a heap of apples problems, when we had, I don't know, the balloon floating in the air, and we knew you were 50 feet from the point, and the balloon was
150 feet?
100, okay, well, I just wrote 100 feet high, and we wanted to know the angle of elevation. When you did that, you set up tangent, you did opposite over adjacent, and you said 100 over 50, and to get it out of your calculator, you had to punch inverse tangent to get that angle, because every time you want the angle, you're asking for the opposite variable. Normally, you give it the angle, and it gives you the number value. You want the reverse. You've got the number value, you need the angle, you got to do inverse. So, you'll be strictly doing inverses on these. Okay, y'all gonna be excited about this one.
Double excited?
Double excited. Gonna bring back something you love from algebra.
Let me get proof.
No. Your proofs that you just did were verifying those identities. You've done your proofs.
You say proofs one more time. Everybody loves proofs. I hate proofs.
Okay. Oh, this one's in degrees too.
I have strong feelings. There you go.
So, what bugs you about this one?
It's the fact that you're in the outside question equals 0 already.
Well, it's equal to 0.
I don't know.
Can you factor it and solve it? You got a sine and a cosine. How can you do that?
Sine squared equals something.
If it's 2 terms, more than likely you're just going to be looking for a common factor, which there isn't. So you got to get that all in one trig function. So how do I get it all in the same trig function? Yes, fundamental number 6 you're going to use a lot. If you have sine and cosine in the same problem, this baby is your friend.
And now if you factor FOIL it.
We want to get rid of sine squared, so we would say it's equal to 1 minus cosine squared.
Yep, right.
So that whole thing becomes 1 minus cosine squared, but you still have the plus cosine. It did not go away. But now it's all cosines and it looks very quadratic. Do you like it in its current form?
You got 10 seconds.
Are you serious? Oh, rats.
We're going to pull on